Hi everyone. What I want to look at today is this area of indices where we're dealing with um, indices that are fractions. One of the questions you had to do for me for homework was this question here, 16 to the power of a quarter, and you were told to use the law to figure out the answer. The law sounds confusing, and that's because it's representing all the different numbers with letters. But when we break it down, it's actually very straightforward. If I ever encounter a situation where I have a whole number like 16 to the power of any fraction, now we're talking about a simple fraction to begin with. If I have, for example, a half, a third, a quarter, a fifth, a sixth, a seventh. In other words, every time if the numerator, the number on top, is 1, and I know the number on the bottom, then I can represent this as follows. I take the denominator, which is the number on the bottom, and I'm going to put that on the left-hand side of the square root, and I'm going to call this the fourth square root of the whole number. So in this case, the fourth square root of 16 means what number multiplied by itself, multiplied by itself, and multiplied by itself, in other words, will have, you take the number and you multiply it 4 times by itself, will end up giving you 16. It sounds like a mouthful, but really it isn't. When you look at it, it can't be 1, because 1 multiplied by 1 multiplied by 1 by 1 again gives you 1. However, the answer here is 2, because this is a number when multiplied by itself. So we'll just put in arrows here to represent this. When multiplied by itself, and again, will give us 16. Okay, so that's the first thing. That is what you encountered yesterday. What we want to look at now is, what do I do in a situation where I have an unusual fraction? Instead of being a half, a third, a quarter, a fifth, we end up with something like a 2/3. So that's going to involve a little bit of manipulation for us. Because if we know the rule that, say for example, if I had 27 to the power of a third, 27 to the power of a third, if I follow this rule, I would take the denominator, which would be 3, and that would be going on the outside of the square root, and I would write down the whole number. So we're going to try to manipulate this so that we can use this law to figure out the question. I'm going to write down 27 to the power of a third. Now I can't just magically make that into a third, but what I can do is I can, on the outside of that bracket, I could write down that it is the 27 to the power of a third squared. And the reason I can write it like that is because we encountered this rule before, where if I have, say for example, 5 to the power of 2 to the power of 3, when I try to simplify that, I have to multiply the two indices together, and I end up with 5 to the power of 6. Okay, so ignoring the answer here, the rule I want you to remember is that when you have a number with an indice, and then there's an indice on the outside, what you do here is you have to multiply the two indices together, and you'll end up with 5 to the power of 6. So coming back here to what we have here, if I multiplied a third by 2, I could assume that's 2 over 1, which basically gets me back to square 1. If I multiply that out, it's the same as 27 to the power of 2 over 3. Okay, so what we can agree on so far is that 27 to the power of a third to the power of 2 is the same as 27 to the power of 2/3. Okay, so the next thing then, having recognized that I can write it in this way, what I can do next is I can simplify this using my normal rule. And that is, I'm going to take my denominator, which is 3. I'm going to write that on the outside of a square root. And I'm going to then write in my whole number, which is 27. Now, of course, that would be okay if that was only 27 to the power of a third. So what I'm going to have to do is I'm going to have to keep my bracket, and I'm going to have to write a square outside of it. So this would be The only thing I'm doing here is I'm changing 27 to the power of a third to the third root of 27, and I'm leaving the bracket as it is. Are we all with me so far? Hopefully you all are. So now you're thinking, what number multiplied by itself again would give me 27? Now you could try 2 by 2 by 2 would give you 8. So clearly that's not going to give us the answer. How about we try 3 by 3 by 3? So when we multiply those numbers by each other, they do indeed give us 27. So therefore the answer here would not be 3 by 3 by 3, but what is the number multiplied by itself? The answer is 3. Not forgetting though that around that 3 I had a square. So therefore the answer is 9. Okay, so let's go through that very quickly to show you what we've done. What we recognized here was 27 to the power of 2/3 is not solvable straight away because the numerator is different than 1. So what I can do is I can use the law of indices to put my denominator on the outside of a square bracket and to put my numerator outside the bracket. Why? Because when you multiply indices and you represent them in this way, they're always multiplied, and in this case, it gets us back to 2/3. I solved the third square root of 27, and I got 3, and all I had to do then was square it to get 9. I'm going to go have a go at one more of these, and then you're going to be finishing this question for homework. So say for argument's sake, I have got, let's say I've got 64, and I have to the power of 2/3. Right. What you should recognize there straight away again, and just apologize there for the lag. What you should recognize there straight away is that when we look at this, 64 to the power of 2/3 is not, again, directly solvable. What we have to do is we have to re-represent this in a different way. So I'm going to write down 64, and for a second I'm going to pretend that this is a third, to the power of a third. But I can't magically just make that a third. What I'm going to do, and what I'm going to have to do, is I'm going to have to put, it'll have to represent this in a way that it would get me back to 64 to the power of 2/3. So the only way to do that is if I put this 2 on the outside, because a third to the power of 2, in other words, that's 2 by 1, which is 2, and that would be 2 over 3. So 64 to the power of 2/3. I'm then going to try to solve this further down. So we have the cubed square root of 64, and that's going to be to the power of 2. So then what I do then is I work out, well, what number multiplied by itself again would give me 64. So if I go over to my rough work, okay, 3 by 3 by 3 gives us 27. That's obviously too small. So how about if I try 4 by 4 by 4? Would that give me 64? It would. So that would be 16 by 4, which is 64. So therefore the answer here is 4. But I'm not quite finished just yet. The answer for 64 to the power of a third is 4. But what I have to do here is I have to square this, and I get an answer here of 16, bringing down the square value. So the answer there is 16. Right. So this is then how you solve where you have a normal fraction. Okay, so now I need to get out of this, and what I need to do next is I need to look at question 7, number 2. So in this question here, if we just have a scan of them, you can see here we have negative numbers. So when you're dealing with negative numbers, again, you have to take your special care because these negative numbers, we've encountered this rule before. Let's say, for argument's sake, I have, if I was told I have 9 to the power of minus a half. Well, based on our indice rules, you could re-represent that. The way you would re-represent it is you would put using the indice rule, you would bring your negative indice below the line. and that becomes a fraction. It would be 1 over 9 to the power of minus a half. Or rather, not minus a half now, we just change it from a negative to a positive. So it's now equal to 1 over 9 to the power of a half, which is the same as 1 over, now, 9 to the power of a half, automatically at this stage you should know that that is the square root of 9. So therefore it's 1 over 3 is my value. So you're using the rules we have seen already. You need to know this rule here. Any number to the power of a negative sign. So let's have a look at another one here on the right. If I have, for example, 3 to the power of minus 2, I can change that equal to, so hold on now, this is catching up with me. I could change that to 1 over 3 to the power of 2. Okay? That's based on the law of indices I introduced the other day. That would be the same as 1 over 9. So when you have a negative, any negative indice, you can bring it below, you can bring the whole number down below the line as a fraction. Right, let's rub that out now and focus on the job at hand. So the job at hand here, I'm going to pick out one of the maybe more advanced questions. Okay, we should all be okay with dealing with halves. But how would we deal with a situation where we have, let's say for argument's sake, I have 9 to the power of minus 3 over 2. Hopefully that will catch up for me. Right. So looking at this one here, 9 to the power of minus 3 over 2. The first thing I need to do is I need to solve the negative sign. A negative indice is no good for me. What I'm going to do is I'm going to recognize that when I have a negative indice, I can always put the whole number and indice below the line, and that'll become a positive then. In other words, it'll become 1 over 9 to the power of 3 over 2. And that is solving the first part, which is the sign. So once I have that much done, the next thing I need to do then is I need to solve the fraction. So let's pretend for a second we have 9 to the power of 3 over 2. In fact, I'm going to write this now as, we'll call this rough work. Right. So I have rough work here, and I know that we have 9 to the power of 3 over 2. So what I want to do again, remember, if I have a number that is a numerator other than 1, then I'm going to have to change the form. So what I'm going to do is I'm going to pretend for a second that instead of having 3 halves, I have 1 half. And to do that, I have to have a situation where I'm going to have to the power of 3 on the outside, because a half to the power, so 9 to the power of a half to the power of 3 is the same as 3 over 2. I can re-represent that as the square root of 9. And again, remember, to the power of 3. In actual fact, that is the square root of 9, which is equal to 3. And 3 is going to be to the power of 3. So therefore, the value here is 27. So if I had to figure out what is the value of 9 to the power of 3 over 2 alone, the answer I would get would be 27. But what I'm being asked is what's 1 over 9 to the power of 3 over 2. And the answer for that is 1 over 27. Okay, because I figured this out on the right here. So there's a little bit of steps involved in this. I suppose there's a lot of steps involved in this. But really, in order to understand indices, you need to know all of your rules and in very good detail. You need to know how do I deal with a negative indice? How do I deal with a fraction indice? How do I deal with a fraction, an awkward fraction, like for example 3 over 2? So once you know all of that, this will become very simple, but you just need to practice it. Okay, so that's it for today, and your homework will be assigned in Google Classroom.